All right, so today's video is going to cover, this is 2.4 day 2, and we're going to get into what we like to call piecewise functions. You've already worked with these just a little bit when it comes to introducing functions and evaluating them. So hopefully something like this notation you've seen, it was even on our first quiz. However, today we're actually going to graph them by hand. So you are going to want to have out your notes for this as well as a graphing calculator so you can practice how to use that in assisting you with getting the points you need to make the plots and the graphs that you need. All right, so a piecewise function means that you have two or more functions and you're only going to keep part of the actual graph to represent the domain that is stated. So you'll notice here we have g of x, which is the same thing as y. This is just function notation. And we have two equations. Now, if you aren't sure which type of equations these create, I would suggest that once you have this in your calculator, just going ahead and looking at the graph, which we will do here in a second, so you have an idea of what type of graph you're creating. That'll also tell you maybe how many points you should try to graph or plot to make sure your graph looks good. All right, so first, here are our two equations. So I'm going to go ahead and go to my y equals button, and I'm going to enter both functions at the same time. So again, remember, even though it's a g of x, we are putting this in the y equals, and we have x plus 6, and then we say y equals 1/2 x minus 4. And I'm going to list them in the same order that they're listed here so that I have no confusion as I'm going to different screens on my calculator so that I can find what I need. Now, before you actually go to the table of values, which, by the way, as a reminder, you would hit second and graph, and then so that would get you to the table for each. Now, when you have more than one graph plotted at a time, what will happen is it'll give you one row of x's, but then you'll have the y values, or an xy table. The first row of y values goes for our first equation, the second row for our second equation, which means we're able to see both set of points at the same time. Now, when it comes to showing your work on the test, what I would suggest doing, and I could do this here in a second, is making a little XY table to the side of your equations here so that your professor knows which points you decided to plot so that you have some work to be shown to go with your graph. All right, so if you wanted to, real quick, once you have these put in, you could actually just see what these graphs are. So if you aren't sure or weren't sure, these are going to be lines. But we're not going to keep the whole line, so our job now is to figure out which part of this line are we going to keep based on where our domain is at. So here's where this inequality notation comes into play. So first, we only want to keep our first equation, or we only say it's valid for this function, when it is less than or equal to -4. So if we go over here, and I purposely put my cursor at the -4, we only want the points for this first equation from -4 and below, which would be -4, -5, -6, and on. Now, I've kind of just taken a picture of my table, but you could continue going up further if you want. However, with a line, the minimum number of points you need to graph the line is just 2. So, as long as we have those points, we should be good. Now, here's how you could be showing work on your tests for JCCC. So what you could do here is you could just say, all right, here's my XY table, because you're going to be looking at your calculator and you need to put this on the paper so they know what you're looking at. And you would say at -4, which is where I would suggest starting since that's where our domain is. So since we're at -4 here, I would suggest starting your table at -4 and say at -4 my value is 2. And then do at least one other point since this is a line. At -5 it's 1. But if you'd like to do a third one just so that you have a chunk to go on here, we can say -6 and 0. So there's our table of values for our first function. All right, now let's go ahead and go plot this. Now you'll notice, and we've kind of already had this discussion, where sometimes you have an open or a closed dot. Since this particular function has the or equal to, we will begin this -4 with a closed dot. So it's almost going to look like array. And we're going to start with a closed dot sitting here at -4, 2. Then we'll go -5, 1. And that should be enough points, but if you would like, you could also put that next point in at negative 6, 0. Now you'll notice we're slowly progressing. So we started at 4 and we're supposed to be going less than. So our domain here should be everything at negative 4 and to the left as far as x is concerned. So when I draw this graph, even though this is the graph, you can see down here in blue, this is the entire graph. The only part that we're actually keeping is from this point, that direction. So we only want to keep the left side of this line. And so when we graph this, instead of graphing the whole line and in essence erasing what we don't need, we just plot the points for what we need, we connect the dots, and we draw an arrow that direction. So that is the graph of y equals 6 plus x for the domain where x is at negative 4 or less. And now we're going to duplicate this. I'm going to change my color here so it matches. Now we're going to duplicate this process for our other equation. All right, so if I wanted to show my work, I'm going to try to get this in here, and make an XY table for my second function. Again, because you can't take a screenshot of your calculator screen and have that on your test. So we got to put something on the paper that our JCCC professor sees. And I'm also going to start this one at negative 4 because even though negative 4 is not in this domain, since there is no or equal to, I still need to have a dot at that spot, and the dot will be an open dot, not a closed. So I'm still going to start at negative 4. Now, as far as this one is concerned, again, you only need a couple. Sometimes you can see from your table of values, sometimes if you don't want to graph a fraction, it may be easiest to maybe pick this point and this point. So we would maybe do negative 4, negative 6. We for sure need that one because that's where our graph starts, or that's where the domain for the part of the graph we're keeping starts. And then if you can go ahead and put the others in there. If you want negative 3, negative 11 halves, which is the same as negative 5.5. And then we have negative 2, negative 5. And again, you can plot more than that if you would like. But again, this is the graph we have. And we're going from here and keeping this part of the graph. So we're keeping the red line down here for the values at negative 4 and larger in our domain. So I'm going to go negative 4, negative 6. And I'm going to put a open dot. Then I'm going to just plot some other points. So we had negative 3, 5.5. And negative 2, negative 6. Sorry, negative 5. And then we'll connect those dots for all of the domain where the x is greater than negative 4. So we have now kept the line or only plotting the part that matches that domain. So we call it a piecewise because you're piecing together parts of graphs. It's not going to be all lines, which is why sometimes seeing the graph is nice. So while this graph really doesn't play into the problem too much, it's at least giving you an idea of where the line should be. And then the table might be the easiest location to go and just get points from. You could definitely sit here and trace these lines if you would like to get the points you need, but the table might be the easiest way to get those. And I feel like this is a good chunk of work to put on the paper to show how you knew these graphs. Keep in mind, there really shouldn't be a gap. So you'll notice that where one domain ends, the other one begins. So you'll notice that these two dots here and here are directly above and below each other. Sometimes they'll even overlap. In this particular case, they didn't. But that's why we have a closed dot on one, open dot on the other, because that's signifying where the or equal to and the one that doesn't have the or equal to. So that would be the piecewise function graph for this particular function. All right, so now we're going to apply that to a graph that's a little more complicated and has some quadratics. And then I think the homework's going to give you a mixture. There's even one on the homework where you're going to have 3 on the same graph. So similar idea. Go ahead and plot both of these. You're going to clear out the last two graphs, and you're going to plot both at the same time. And again, I would suggest listing them in the order they are so that you kind of know, like the top one was, so you kind of keep it straight. And then keep in mind when you head to your table, again, the first equation you enter. Now mine's color-coded, but the regular just TI-84, it's all just black and white. However, notice it uses this little Y1. So that tells you this is the Y values for the equation you entered first. These are the equations you entered for the Y values for the equation you entered second, so on and so forth. So you should be able to hopefully keep them straight even if yours isn't color-coded. All right, now, if you wanted to hit the graph button real quick, once you have those graphed, you can see that we are graphing some parabolas. So we have to be a little more careful on this one because we want to make sure we keep the shape we needed. And you'll notice on this particular graph that our domain, one is ending at 0, so we're going to keep the left side up to 0, and the other one's going to start at 0 and go to the right. So this is kind of our point of reference right in here, if you can kind of see how our graphs are going to shape up. All right, so again, I put my cursor at the 0 so I can see where my two lines split. So for the first line, since it's a parabola, it may be best if you can. I know some of these bigger values, they're not going to fit. Like negative 33 is not going to fit on this graph. Neither is negative 22 or negative 13. So you might just want to pick values you can make work. So maybe for the blue graph, I do these, just so I can get a good idea of what the curve is. And then for my red graph, or my second equation, I will do, 11's not going to fit, so we'll just do these three. So you might just kind of use the points that you know will fit, unless you're willing to adjust your scale. But usually it's best just to try to keep your scale as counting by ones. It's easiest that way. All right, and again, if you're trying to show work, so obviously this is what you're looking at on a screen, you're not putting this onto the paper. Here's how we could be showing work. So we say for this function here, here's my XY table. I'm going to start my table at 0 because I know that's the point that we're kind of using as our ending point for this particular graph on the domain. And I'm going to do values that are less than that. So -1, -2, -3. And then the values that correlate to that are 3, 2, -1, and -6. And that's the points I will plot for our first graph. Then when it comes to my second graph, I'll make another XY table, again starting it at 0 because that's the point at which this particular piecewise function is ending one graph and starting the next for the parts that we're keeping. So this one's at 0, 2, and then it's going greater than or equal to 0. So our x values would go 0, 1, 2, and the points that apply would be a 2, a 3, and a 6 here. All right, so if we go to plot our points, I'm going to plot my first point here, this 0, 3. Remember, this is not where the or equal to is at, so pay attention to which one has that or equal to. And I'm going to put an open circle at 0, 3. So I still need that point because the graph has to come up to that point, but we use the open circle to show that 0 is not part of the solution. It's just all the way up to that, but not including. And then I'm going to plot those going to the left. So we have -1, 2. We have -2, -1. And let me scooch that over just a little bit. -3, 1, 2, 3, 1. -6. And since it is a problem, I'm going to do the best of my ability to make this look like a nice little curve. I promise you they don't get too picky on this as long as it appears you're trying to actually hit your points. Oops, let me try that one more time. And there is the graph of 3 minus x squared for a domain at 0 and less, so x less than 0. All right, now I'm going to start my next graph with an enclosed dot because that's where the or equal to is at, and that's at 0, 2. Then I have a dot at 1, 3 and 2, 6. And that next one was at 311. Was it 311? Yes, I might be able to, we can guess where 11 would be, roughly in there. And then we're going to sketch that side of our graph. Now, since it's a piecewise, it means no two functions should overlap. The only place where that overlap happens is right when they're changing spots. But again, one's going to be open, one's going to be closed, so they really don't overlap. But so when one ends, the other begins. But you'll notice I don't keep parts of the graph like this one. It does continue this way naturally, but this would be an overlap of graphs. So you notice you have graphs that are overlapping almost completely. That means you've probably kept more of the graph than you're supposed to. Now, your homework only has 4 examples in it, or 4 practice problems, because these are kind of tricky. My best advice to you would be just to practice how to get your XY tables for each item. If you don't like using the graphing calculator, you could always try to create these tables from hand. It does take a little bit longer, but it is possible, so I can assist you with that if you would like. But in general, it's just making sure that we get the points we need, getting a good idea of what the graphs look like to make sure that even though we are only graphing part of each graph, we can kind of still get the essence of what the part looks like that we're keeping or that the domain is having us keep, so that as a whole, our piecewise function graph looks accurate. And that is 2.4 day 2.